Which way will the north pole of a compass point at the location of the circles? Here we have current in this example right here. We have current that's going around in a circle that is counterclockwise. Current counterclockwise. So what you got to do is you got to figure out how to curl your fingers like that, counterclockwise. That's direction of positive current. Your thumb will point to the North Pole. So how do we indicate this on here? Well, if it's counterclockwise, your pole will be like this. This is the magnetic field right there. That'll be the B field, like that, out towards you. How about out here? Which way will the B field be out here? Well, if this is the North Pole coming out towards you, it's got to curl around and go back the other way to get into the back of behind this screen. That's how the magnetic field will be outside of this coil of wire, going back and coming back around and coming into the South Pole, which is at the back of this electromagnet we've created behind the screen, and then it comes back out the north end, which comes out towards us. North Pole will point out towards us. Here's another magnet that I've shown right here, and this is a more common way of forming an electromagnet. Notice that this is the positive side of this electromagnet right here. There's the positive. There's the negative side. So if we follow the current, current is going this way. That's the direction of current. So we got to follow this around. Which way do we curl our fingers? When it's wrapped like this, current goes in front of that nail right here, and it curls around behind the nail, and then curls back in front of the nail, and then behind the nail. So the only way to do that is to curl your fingers like this. Fingers curling like this in the direction of the current that goes around. It doesn't matter which end is first. Doesn't matter that this is the positive end, this is the negative end. What matters is that it's curling around like this. When you do that, what you get is the north pole of the electromagnet will be over here. That'll be north, and this will be south, meaning our compi will do this. Compass right over here will point out like it points away from the North Pole. That's where our compass will point. And over by here by the South Pole, it'll point into the South Pole. And then when it curls, the magnetic field curls back around, it'll point to the right. Let's go and do another example. Let's try example C right here. In this example, we have the positive end of our battery right here and the negative end over here. So in contrast, you'll notice that we're not going to get the positive end connected to the south end of the battery like we did before. Like I said, that has nothing to do with it. What we got to do is we got to trace the current. So in this example, the current's going that way, I. It's also going that way. Current is pointing that way, so you got to follow it around. It's going this way. It curls around behind this nail and then curls around in front of it. So the current's like this and like that. And when you do this, you will see that we get our current curling around like this. On your right, it's coming out of the page. Your left is going back into the page. So you curl your fingers like the current goes, and your thumb points to the North Pole. So the North Pole of this magnet is at the bottom, and the South Pole is at the top. And this is, when you put a nail in there, as we'll find out in a minute, it makes the magnetic field a whole lot stronger. So what I'm going to do next is I'm going to draw our magnetic field lines. They come out of the north end of this magnet. They curl around back into the south end, make a complete loop, and I'll draw those B field. This is our B field arrows, and I'll do another magnetic field line right over here, coming out of the north end, curling around and going back into the south end right there. These are directed that way. That's the B field. So when we put these compasses, these round circles, our compass right here will point that way. The north end will point that way, parallel to the B field. For this one, the north end points right towards our South Pole, like that. And for this one, although it's a little bit off, it'll point that way right there. So that's the direction that our compi will point. Very important note, it has nothing to do with which end is closer or connected to the positive end of the battery. It's all about how the current coils around this thing. Curling around this way means the North Pole is at the bottom, and that allows us to find the magnetic field all the way around. Again, you could use the wire right hand rule and change your direction of your wire and figure that out. Thumb points in direction of current, then you could figure out how the magnetic field goes. But that can be cumbersome when you have a lot of wires, so this coil right hand rule makes it a lot faster.